Let's test and see if these two triangles are right triangles. Notice in the directions it says to justify our answer. We need to prove. We can't just say yes, it's right because it looks right, or no, it doesn't look right. We're not allowed to assume things in geometry, so we need to prove our answer. Our proof in this case is going to be the work. To test if these are right triangles, what we'll do is we're going to use the Pythagorean theorem. In this first example on the left, I'm going to label my sides A, B, and C. Even though if it's not a right triangle, C, we're going to call this the hypotenuse, even though we don't know if it's the hypotenuse yet. If it's not right, it won't be a hypotenuse. But let's call it that just because it is the biggest side in this case. So let's set up the Pythagorean theorem and then do a little test and see if this does work out to be true. If it's a right triangle, the Pythagorean theorem will check out. So I'm going to write 24 squared plus 16 squared equals 29 squared. Now because I don't know if this is true or not, I like to put a little question mark above the equal sign because that's what I'm testing. So let's square these numbers and see what happens. 24 squared is 576. 16 squared is 256. Oops, 256. And then 29 squared is 841. If I add these values on the left together, I get 832. And then again, oops, I should be doing equals with a question mark. 832 is maybe equal to 841, and of course it's not. So because that does not check out, they are not equal to each other, what that's telling me is that no, this is not a right triangle. It's not going to work out. Whether it's acute or obtuse, I don't know that yet. That's what we'll do in another video, but I know for sure that this is not a right triangle. My justification is going to be my work, so I need to see that. I'm going to pause, or you should pause the video right now. Try that example on the right if you want to see me work through it, or my work will show up in a couple seconds. If you're having trouble squaring this number, I'll kind of show you how to do that. But go ahead and pause the video, try that problem, see if you can figure out if that's a right triangle or not. So yeah, that second triangle does work out to be a right triangle. We get the same number on both sides. If you had a hard time squaring the hypotenuse side, the 13 root 3, one trick that I like to do with numbers like that is I break it into this. What I think is the number on the outside, which was 3 in that case, times the outside times the inside number, so outside times inside, is a really quick way to do it. If you have a graphing calculator, it's pretty easy to type in 3 squared root of 13. Just keep it in parentheses before you square it. And don't round it off, because otherwise if you type in a decimal and round it off, you may not get the exact same number on both sides, and you may be led to believe it's not a right triangle, when in fact it indeed is a right triangle.